to reach 56 electrons. I always begin from this point, and as a reminder, S can hold 2 electrons, P can hold 6, D can hold 10 electrons, and F can hold 14 electrons. Okay, so what I do, I work step by step. Okay, so first I have to build my ECN, my full notation. Okay, so I always begin from the very top, and I stop when I get 10 electrons. How? How I know I have 10 electrons? Because I have 2 here, plus 2 plus 6 gives me 10 electrons. So I start writing the configuration. Okay, so here I have 1s2, 2s2, 2p6 in the first place. But I need 56 electrons, not 10, so I need to continue. So I continue with 3s, I follow the dash line, continue with 3p, and I follow the dash line to 4s. I know that over there I have 10 more electrons because I have 2, 6, and 2, that makes 10. So I write the rest of the configuration like this. 3s2, 3p6, and then 4s2. So right now, here I have 10, and here I have 10 more electrons. So I'm going to continue. I need 36 more electrons, so I will continue. And I say, in the third step, I will continue with this. I have 3D, 4P, and 5S. And I don't forget that S is equal to, P equals 6, and D equals 10. So I'm going to write the rest of my configuration over there. It's going to be 3D10, 4P6, and 5S2. Now, in here I have 10 plus 6 plus 2, 18 electrons, which means that I have 20 plus 30 plus 18, I have 38 electrons, but I need 56. Okay, which means that I need how many more electrons? How many more electrons I need to get 56? I need 18. Okay, so that means because I need 18 more electrons needs, I need to continue. So I continue with my tree, and remember that D is 10, that P is 6, and that S is 2. Okay, so in my next step, I follow the dash line, and then I copy the rest of my configuration. So I have 4D10, 5P6, and 6S2, which gives me 18. Okay, 10 plus 6 plus 2 gives me 18 electrons. So 18 was exactly the number I needed to complete my 56 electrons. So I can say that I already finished, but I also need to make sure that I did it correctly. So just to make sure I did it correctly, I will add just the electrons, 10 plus 10 plus 18 plus 18. this should give me 56. Okay, now that you have checked that you have the 56 electrons, I already checked, so I have 56. Now I have to focus on the periodic table. Barium, which is number 56, okay? Number 56. What is the noble gas, Gerard, that is before barium? What is the noble gas that is before barium? Barium is right here in the position 56, okay? Okay, and I'm going to look for in the periodic table what is the noble gas that is before. So that means that I need to go back, okay, and look for the next noble gas. The next noble gas that is exactly before barium is xenon. Xenon, which has an atomic number of 54. So this is the element, this is the noble gas that is going to work for us. So we say xenon is the noble gas located before barium. So we're going to choose xenon. So we say xenon, which has an atomic number of 54. How many electrons, Gerard, how many electrons I need to be barium? How many electrons I need to be barium?
How many electrons do you need to? You need 56.
Okay, yes, you need 56. But now you have the 54 from xenon, okay? So how many more electrons you need to become barium?
2.
I need to add 2 electrons, okay? So I'm going back to my electron configuration, and in this point I will begin from the very end, okay? I will start to count electrons from the end, okay? And backwards. Now, because I just need 2 electrons, I will include the only portion of the electron configuration, the very last that has 2 electrons, which is 6s2. 6s2 gives me the exact number of electrons that I need to become barium. So my configuration is going to be xenon, which has 54, okay, and I will complete the configuration with the last portion, that is 6s2. The only reason is because it gives me the amount of electrons that I need, 2 electrons. So here, to make sure that you did it right, you're going to count the electrons. 54 from xenon plus 2, which gives you 56. And as you already know, barium is 56, so we say that we did it right. Another way to check it is looking at your periodic table. In barium, in the bottom of barium, you have a configuration over there. Tell me, The configuration from your periodic table is the same that you see right there, or is it different? Is it the same?
Yes.
It is the same, okay? So in that way, that's your second method for you to see if what you got is correct. Okay, so keep the periodic table with you so you can check that the procedures that you are doing are the right procedures.